So basically, recursion and recursively defined sequences are sequence of numbers like we have in example 2 here. 2, 5, 8, 11. What is going on when they go from 2 to 5, then 5 to 8? Yeah, it's just adding 3. So obviously, it's not about doing sequences. You've done sequences seriously since you were in 2nd grade. Okay, but it's about learning a new notation for writing a sequence of numbers. All right? And recursion is the process where everything depends on the number in front of it. So for instance, this 5 depends on the 2, and you did something to the 2 to get the 5. Now, even as simple as even numbers that you learned again in 2nd grade, 2, 4, 6, 8, that's a recursive sequence. The hard part here is learning how to write it in this fancy way that we get to down here. This is an example of a recursively defined sequence. You're going to be able to write those by the end of the day today. It's really not that big of a deal. Okay, let me try to explain it to you. If I go back up to this sequence, 2, 5, 8, 11, it's where you're adding 3 each time, right? Would you agree that if I wanted to, I could call this A, B, C, D, etc.? All right, well, in a recursively defined sequence, they don't use a different letter each time. They use the same letter with a different subscript. So like I could call this U1, U2, U3, and U4. Those are U sub 1, U sub 2, etc. Does that make sense? Would you agree that usually when you count, you start with the number 1? All right, so then U sub 1 is the logical first term. Now, would you agree that you could start with U sub 0? You ever heard of starting at 0? I know it doesn't seem right, but you can start with U sub 0 just as well as you could start with U sub 1, and that would change things. If you wanted to make it the year that this happened, like I had 2 marmots at my house in 2015, it'd be U sub 2015. So I can start with anything I want. So in a recursively defined sequence, you have to tell the person what you're going to call the first term and what the first term is. So do you see that they are saying we're going to start with U sub 1, and the first number in our term is a 5. First number in our sequence, I'm sorry, is a 5. That means my list is going to be 5, comma, something, comma, something, comma, something, and it'll go on forever. But the very first one is 5. Okay, and again, we're starting with U sub 1 being our first term. That is the most common way, but again, I want you to know, you can start with U sub 0, or they can tell you to start with U sub 2009. All right, so the first term's 5, and all this big mess here, blah, 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 and then what do you think the plus 4 means? Let's take a guess. What does that mean in my sequence? Yeah, you're going to take whatever the number was, and you're going to add 4 every time. That's all. So what is all this stuff? U sub n and U sub n minus 1. All right, U sub n, what the heck? That's U sub some number. All right, if I had a list of terms like, we'll go with the classic, 2, 4, 6, 8, 10. That's the even numbers, right? And it goes on forever, so usually put a dot, dot, dot. Okay. Then if I wanted to pick some number way out in this list, like, 216, comma, 218, comma, 220, comma, dot, dot, dot. There was numbers before it and there was numbers after it, and I don't know which term I'm on. If I don't know which term I'm on, because I don't want to take the time to count it all the way out there, do you get that if I take a random term out of my list, I could call it U sub something? U sub n. U sub n means like a randomly chosen term out of your list. I don't know if it's U sub 1, or if it's U sub 30, or if U sub 37, I don't know. But it's U sub something. Then what would the number right in front of it be? Think about it. Yes, sir? You got it. Because whatever this was, if it had been a 20, then this would be 19, right? It'd be whatever that one was minus 1. How about the term right after it? U sub n plus 1. Now, which of those do we see in our sequence thingy? The u sub n and the u sub n minus 1. What does u sub n mean? Any term. What does u sub n minus 1 mean? The term right in front of that one. So, now that you understand that a little bit better, if you look at this, I hope you see that this is saying any term is given by or is equal to the term right in front of it plus 4. You see how it's just a different language? It's a language of math. It's not German or French or Swedish, but it's a different language saying your first term is 5. And we're choosing that to be our first term is going to be counting with 1 as our first of the terms. Then any term is given by the term in front of it plus 4. All right, if you really understood what I just said, would you please tell me, and don't just ignore this for a moment, it's too complicated for right now. Just tell me what the first 4 terms are in that sequence. Give you a hint, the first one's 5, comma. Give me the first 4 terms. And turn your iPad my way, and I will tell you whether or not you are doing it right. I'm learning a new way to do this. You have it on tilt. You turn it my way, and I'd like you to just have, just hold your finger up at your desk. Choose wisely which finger. And I will, if you are holding your finger up, just kind of gives me the idea that I haven't checked yours yet. Okay? And I will say, I'll give you a hint like how to fix it. You added 3, I think. I was looking for 4, and that's what I was looking for. Yup. And if once I've done it, then leave your iPad my way, because then I can tell I've already checked yours. But if you don't have a finger up, see, here's the thing. I got feedback from kids, and kids said, you sometimes don't check mine. Well, I didn't know that I didn't check yours, so you just have to hold up a little finger, and I'll be able to know that I haven't checked yours yet. Okay? And could you zoom yours in a little bit, because it's hard for me to read? And that is correct. Yes. If I haven't checked yours, just hold a finger up. Just one finger. All right, good. Yes. I'm trying to train you to get used to this. And keep it my way, though. Keep it turned my way, because then I can tell who hasn't answered yet. You went past 4 terms, but you were fine. You got the right idea. Yes. You're adding 3. This one adds 4. Yes. Who haven't I checked yet? Yes. Still waiting for a couple people in the back. Turn it my way. Keep it my way. I know that's going to be a hard habit to break, but that way I can tell who hasn't answered yet. Miss D? I'll have... All right, so moving on. It was 5, plus 4 is 9, plus 4 is 13, plus 4 is 17. There we go. That'll go faster next time now that you're used to the system. All right. This next one, without any further ado, do the next one. First 4 terms. Starts with 12. And I think probably less painful for you is if I am not checking yours and you kind of want to be checked, then hold up a finger. And if you don't hold up a finger, I'll try to remember if I've checked it or not, but I might not be able to tell. It's your responsibility. If you want to be checked, just hold up a finger or something. I'll tell you if you're right or not. That is right. And don't feel bad. Good. If you did something wrong, that means you're going to learn something, and that's good. I will make plenty of mistakes, and you guys probably won't laugh at me. Yes. Oh, I see the first numbers there. Yes. And yes. And I can't tell who I haven't checked now. Good. And if you don't laugh at me, I'm not going to laugh at you. We'll be nice to each other when we make mistakes. It's really, really crucial in the math classroom that you feel comfortable to ask questions. So, for instance, when you have questions, you will never, as far as I can remember back into time, no, I shouldn't say that. I wasn't as careful about this when I first started teaching, but in the last several years, if somebody asks me a question, I won't say, I already covered that, you should have been listening. You know why? Because that makes everybody petrified to ask the question, because like, if somebody already asked this, he's going to belittle me, he's going to like yell at me. I will never do that to you. If somebody asked the question already, I will just answer the question again, because repetition is good. That's how they get you to buy things on TV. That's why I know 800-988-2300. You know what I'm talking about? Empire, very good. See, they got it in their heads. Just repetition, they just kept pounding on it over and over again. So a little repetition won't hurt anything. All right. Arithmetic is a special kind of sequence where each term is equal to the previous term plus a constant. That basically means you are adding. The kind we were just doing is adding. It's just sometimes you're adding a negative number. Okay, so it's arithmetic. Either way, if you're adding or subtracting, that's called arithmetic. And notice I'm not saying arithmetic. The correct way to say this is arithmetic. Would you please say it after me? Arithmetic. All right, good. Don't say arithmetic sequences. Arithmetic. All right, and the number you keep adding over and over again has a name. It's called the common difference. That's a typical kind of thing we might ask you on a test. Is it a common difference or a, well, if you are multiplying by something every time, it's not called a common difference. You'll find out in a second what that's called. All right, this activity I would like to actually try. You're going to come up with a sequence. You're going to pass it to the person next to you. Actually, you're just going to turn your iPad their way. And then you're going to try to figure out the first 3 terms, just to save us time, of their sequence. And they're going to figure out the first 3 terms of your sequence. All right? So, as you write your sequence, I'm going to give you some help on how to write these sequences. So what your job is, for instance, I come up with this all-powerful one, 2, 4, 6, 8. No, you can't use the odds or the evens. I'm using it as an example. Okay, you come up with some other sequence. And then the person's supposed to write back that, okay, U1 equals 2. And then what else would they say? UN equals UN minus 1. And then what's it doing? It's adding 2 each time, plus 2. That would be the answer to their sequence. All right? Before you do this with somebody else, do it for me. Here's mine. 12, 17, 22, ... Would you please tell me what you think my sequence is? And then I'm going to have you see if you agree with the person sitting next to you. It's going to be these 2 rows are going to be looking at each other's. Miss T, you're going to have to do a triangle with the 3 people there. Okay? And just for today, Mr. B, would you move up and sit in that seat so you'll have somebody right next to you? And it's going to go these 2 rows. And then you guys will make a triangle right here. So you 3 will compare with each other. Okay? And then these 2 rows can work together and you guys make a triangle back there. Awesome. All right. Remember, you can start with u sub 1. Technically, please do start with u sub 1 because you could have started with u sub 0 or u sub 2073. Start with u sub 1, please. See if you and they think you got it. I'm going to pause for a second. Let me give that a try. Okay, that was awesome. Don't feel bad if somebody's teaching you something. That's okay. You're all going to be in that position sometimes where you know how to do it, and sometimes you're in a position where you're not able to do it. U1 equals 12. Why? Because you start by saying what the first term of the sequence is. Then you always say this. UN equals UN minus 1. That's going to be in every single sequence you ever write. Okay, so just get used to writing that little series there. And then you have to say what's happening. We're adding 5 each time. So that is your recursively defined sequence. That's it. All right, did you notice there was something on the other sequences that I said, just ignore it, it's too hard for now? All right, I think you've got a big enough understanding of this now that I can add that part in. When you have these recursively defined sequences, they don't work for every single number. There's one number that they won't work for. It'll tell you to look back at the term before it, right? This is saying to get any term, look at the term before it, and then add 5. Which term doesn't have anything before it? Look at all these terms. Which of them doesn't have anything before it? 12. This is the only term that it won't work for. So that little thing at the end is like a caveat, kind of like the lawyer language that says minimum APR is 5.6%, blah, 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 blah. And they say it really fast because they have to do it because it's, law. Well, this is saying this formula only works when n is greater than or equal to 2. What it's saying is you can't be 1. If n was 1, this formula wouldn't work. Because n is the term on the bottom. If this was a 1, it can't predict that. This is u sub 1. It cannot predict what u sub 1 would be. You have to tell it what to start with. Now, could we logically just think, well, it probably would be subtract 5? Yes, but in the real world, sometimes things don't work until it hits like 10. Like before that, you don't have numbers that will work. I can give you examples like the Fibonacci series. Always when you divide the two numbers, it comes out to the golden ratio, except it doesn't work at the beginning of the series. It only works after a certain amount of time. Anyway, so this is called a domain, and all you have to remember is that this number right here is always 1 bigger than whatever that was. If it starts as a 1, then this will be a 2. If I had started at 0, then this would have been a 1. Let's look back at the ones that they gave at the very beginning of the lesson here. Look at this. It started with 1, and so it ends greater than or equal to 2. If it had had a 0 right here, then this would have been a 1 right there. And it's saying it won't work for the first term in a fancy way. All right, that's one of the hardest concepts to get about this. So if you're still a fuzzy on that, don't worry about it. All right, there were a few hands, and I avoided them till now because I thought I might be able to answer the question. But are there any questions still lingering out there? I do want to answer them, but sometimes I know I'm about to explain the common question. Okay, so let's move on. This is officially example 1, but you're already pretty smart, so this should go pretty easy. So here's the sequence: 20, 13, 6, -1, -8. What's the common difference? I got a hard question for you. Is it 7 or -7? -7. Because you need to subtract 7 to get from there to there. All right, -7. What recursive formula generates the sequence? Would you please write down what you think it is? And I betcha some of you will forget how to do that last thing we just talked about. Add the domain at the end. N is greater than or equal to blah. All right, give it a shot. And I'm going to pause for a second while you answer that. Okay, thank you. And you guys were sharing very well, and that's great. It doesn't seem like you're being too shy, which is the most important thing. All right, what recursive formula? I would start with u sub 1, and that's 20. And then it's a u sub n minus 1. And then what's happening each time? -7. So you just put a -7. And then here's the easy part to forget. N greater than or equal to, and you look back at this number. If you started with 1, you say 2. That way, obviously, it doesn't work for 1. Why? Because there's no number in front of 1. All right, what's the 11th term? Raise your hand if you've got it. What do you think? -50. Can anybody verify that? You agree? Or are you, because it might not be right. And there's confidence. That's good. Does anybody else get that answer independently? Be honest. Maybe nobody has even checked the 11th term. All right, so how do you do this? Do you actually have to do it 11 times? Holy smokes. Yes, you do. But very quickly here, we're going to be getting you into calculators, where the calculator would be doing all the work. And this is just kind of needless, painful grunt work. Really, if you think about it, if you're doing -7 11 times, aren't you going to basically just take 11 times -7? Which would be like taking away 77. Doesn't that make sense? So if it starts at 20 and you take away 77, I think it's not -50. Okay. All right, good. So, yeah, it's painful, but you would just keep going. And 1, 2, 3, 4, 5, that's the 5th term, u sub 5. You're going to learn how to do this in the calculator so you don't have to actually go out to the 11th term and keep going. And just all you have to do for right now, from what I've taught you, you just keep subtracting 7 each time. This will be -15. Subtract 7 again, -22, etc. Okay, moving on. This is a way to show you that this theoretically could be used in the real world. Now, recursive sequences are used in the real world a lot, but they aren't usually written with this special recursive notation. Okay, but this is just on notation. There are many notations in math that you'll have to get used to. If you want to be an engineer, there's other notations you have to get used to. Matrices are another type of notation, and you're going to learn those later this year. There's just different ways to do problems and different ways to write them. All right, I don't like this problem very much, so we're going to skip it. Geometric sequence. Each term is equal to the previous term multiplied by a constant. What's different? You're just multiplying. The other kind was called, I made you say it out loud, arithmetic, and this one's called geometric. And instead of a common difference, this has a common ratio. All right, so it's the same exact idea. I start with u sub 1 equals 10, and let's say I multiply by 2 every time. I said always, un equals un minus 1. And then if I'm going to multiply by 2 every time, I just say times by 2. And then what do I always need at the end? The domain, n greater than or equal to 2. Do you get that I start with 10 and I multiply by 2 and I just keep going? Make sense? That's called a geometric sequence. The common ratio then is what? What that means is if the first two terms are 10 and 20, you get that if it's times by 2, it would be 10 and 20, then ratio means a fraction, right? How do you get it? 20 divided by 10 is 2. See, it's a ratio. 20 over 10. It's this one divided by that one. 20 divided by 10. So if I start by saying, here's my sequence and it's geometric, and it goes 2, 6, 18, ... You get I'm not adding something each time. I'm multiplying, right? What am I multiplying by? 3. And you could have gotten that by saying this divided by this. 6 divided by 3. That's a ratio, or 2, sorry. And it equals 3. That's why they call it the common ratio, is it's a ratio of this one to that one. Okay? That's common ratio. Here is a pattern question, and if we're at stage 0, that's like u sub 0. And then how many triangles are there at stage 0? There's only one big triangle. 1. u0 equals 1. Do you get how I'm turning this into a recursive sequence? u sub 1 is my next term, I guess you'd say. And it's got a lot more triangles. It's got the one on the outside plus small ones, which there are 1, 2, 3, 4 of them, so that's going to be 5. Is there 5 triangles? Oh, so that's how many red triangles. Good point. So then I subtract 1, and it makes it 4. The big one is not a full solid red triangle. Good point. That makes it 3. Remember that part about me making mistakes? Thank you for catching them. And it's going to happen. It's okay, too. All right, on to the next one. How many red triangles are there? U sub 2. Notice I'm staying consistent with this. Some people would have started with U sub 1 and it would have gotten really confusing, but I knew that since this had a 0 here, I should just start with U sub 0. All right, how many triangles are there? The red triangles, to clarify. 9. It's going 1, 3, 9. Can you tell now? Once you've got 3 terms, you can usually tell what's going on. It's just multiplying by 3 every time, isn't it? All right. So then, if you were going to have to write this out, since the common ratio is times by 3, then all you'd have to do is say u sub 0 equals 1. Do you have to start with u sub 0? You don't have to, but I think it would make your life much more complicated actually to start with u sub 1. That way the stage number is always this number. All right, u sub n minus 1, so I was going to have that. And then I just times by 3. And then my domain, n greater than or equal to, be careful on this one, 1 this time, because I take 1 bigger than that number. All right, you have learned to do sequences. So your assignment is on sequences, and it's geometric and arithmetic, which are the two kinds that we just talked about there. And you'll find it in the normal spot in our Schoology page, right in here. And there's one worksheet on arithmetic and one worksheet on geometric. And my feeling is that with today being a shorter day than normal, because you've had so much get to know you stuff at the beginning here, I don't want to assign all of this. It doesn't feel like a realistic amount of homework to ask you to do. So I'm going to ask you to just do the evens on both worksheets. So you're going to be skipping number 9 right there anyways, although I kind of like that problem, but it's all right. We may come back to some of them in class tomorrow. But all right, so your assignment is to do the evens on both lesson 1 arithmetic and also on the lesson 1 geometric. So these two worksheets right here, just do the even problems only. Okay? All right, now for those of you that are new, or we're in a different hour, homework is put into the gradebook sporadically. It is not every day, just because I don't want to spend 5 minutes every day grading the homework. When we do grade it, it'll be often graded by a fellow student. I'll tell you where to hand it, forward, backwards, sideways, whatever. And then the grades are put directly into the gradebook. So homework does matter, and I will give you incentive on this one. I am putting this in the gradebook tomorrow, for sure. Okay, so get your homework done. You don't want to start off on a bad note of not having your homework done on the first day of the new semester. Okay, well, it's nice to get to know my new class. It seemed like it's going to be a nice group. So please stay seated, because I have to get my attendance switched around to match this.